welcome John Stauffer and Beck Payton.
Hello, everyone. Thank you for coming. We're excited to be here to talk about some of the innovations we've been doing in Engine. My name is John Stauffer. I lead the Engine group. I'm here with Beck.
G'day, g'day. I'm Beck, and I head up design for Studio and Creator Hub.
So today, we're going to take a few minutes to talk about some of the innovations we've been doing in Engine from the past year, some of the preview of what's coming, and then we're going to dive deep into three really great topics. I know a lot of you are really interested in these topics. So yes, we are talking about Mesh and Texture API, so you'll get to hear all the deep details. So when we talked last year about making a great engine, we said that a great engine has three key attributes. It has to be fast, it has to be stable, and it has to give you the capabilities you need to bring your imagination to life. So we want to make things that are simple, easy, and we want to make things that are complex possible.
So I'm jazzed to be here because we've made some massive wins for performance and stability in the engine this year. One of the most amazing things about Roblox is that it is for everyone. And so we monitor how well it works for those people, the 25% of people on the lowest end devices and with the least reliable connections. Recent changes that we've made have actually made it more stable by 70% for iOS users. And we're trying to work to get those improvements across the board for other platforms. We're also in the process of rolling out rendering optimizations, and these massively reduce CPU overhead. For example, for Brookhaven on Samsung S6 tablets, we're seeing a 35% reduction in CPU overhead, and we're seeing that for most experiences. So I'd actually like to see a quick show of hands. Who's turned on streaming for their experiences? Winners, love that. So as you can see here, there are significant reductions in join time and out-of-memory crashes for those experiences that have streaming on compared to those that don't. And we see these improvements across the board. It's a consistently performance win, and it really improves the experience for your users. Now that you know this, I bet you're going to all be raising your hands next time that I ask. We've also been making big improvements to our instant streaming system. In fact, we've improved it so much that we've turned it on by default for all new experiences. So now that we've had a look back on performance and stability for the engine this year, John, what's up next?
Thank you. So looking ahead, to achieve this, we've been investing heavily in performance. Let's preview two projects that we're working on that'll improve performance even further. First, we're investigating occlusion culling. Occlusion culling will limit the geometry that we render to only what's visible. This is going to be a great performance win. Second, we're overhauling the internals of the terrain system, particularly with a focus on memory footprint. And we're improving its performance and making it work great with streaming. So for experiences with large terrains, this is going to be a great improvement. And while we're overhauling the internals, we're also improving the quality of the rendered results to give smoother and more continuous surfaces. Performance and stability remains a priority for us, and we're working on many more improvements. Now let's switch gears and talk about some of the capabilities we're bringing to help bring your imagination to life.
So check it, a little bit of a word cloud, love that. These are all the amazing features that we've been releasing in the engine this year, or that we're going to be releasing soon. It's been really cool to see you all adopting these capabilities and the creative stuff that you've been doing with them. But we know it's not all about creativity. We also want to help you keep your experiences safe. We heard you loud and clear that cheating impacts your bottom line. And so we've doubled down on anti-cheat tech. You'll hear more details about this in the talk this afternoon by Safety. Check it out, it should be really great. But let's discuss two of these capabilities right now. The first is on the software side with our Hyperion anti-cheat system. As Dan talked about yesterday, we've seen a massive reduction for Windows exploiters. We also believe in giving you the tools to implement your own anti-cheat systems. Our new API can check out if a user is verified or not, and we're also building out other useful anti-cheat features. For example, we're working on a banning API so that you can ban specific users from your experience. And yes, it does handle alternative accounts. Now, let's get back to the future with John.
So we have a lot of things in the works, some of which Dan previewed yesterday, like the future of lighting on Android with the new GPU light grid, and significant improvements in the avatar motion. So we want to highlight a couple more upcoming capabilities. We're aiming to release unreliable events by the end of the year. Unreliable events makes it such that you can say, it's okay if the event the client is sending doesn't reach the server, for when speed is more important than performance. Speed is more important than a guaranteed receipt. And we're investing heavily in our UI framework, making it work better across platforms automatically. Style sheets make it possible to change the look and feel of your UI with one click. They work with 3D content as well. And flex layouts allow you to flex layouts allow content to responsively and dynamically adapt to the different layouts. We believe these features are going to make it much easier for you to build your UI. Now we're going to do some deep dives, and I'm going to hand it off to Friedrich to talk about the audio API.
Hello. So we are releasing a new audio API, and this is an exciting big deal. We don't often release new instances, new functions, new properties for an engine subsystem, but we're doing it now for audio. So I'm going to first explain why we are doing this. Then I'm going to go over what the new API is and what the concepts are behind it. And then I'll provide some examples of its use and tie it back to our motivations, why we are doing it. So we're doing this for 3 reasons: to help you build complex behaviors from simple building blocks, to unlock some exciting new audio features, and to unify voice chat and sound playback. So we are basing the API around 3 high-level concepts: producers and consumers, wires, and emitters and listeners. Producers are instances that create audio or output audio. An example might be asset file playback. You have a file, and we play it back, and you get audio from it. Consumers, on the other hand, are instances that receive audio. So an example in our new API is an audio emitter object that receives audio and then broadcasts it into your 3D virtual world. Excuse me, went too fast there. Some instances are both producers and consumers. So you're probably all familiar with our effects plugins like chorus, reverb, distortion. Those are both producers and consumers. They take an audio input, they apply the effect to it, and then they output it. Wires are what connects producers and consumers. They allow you to describe the routing of your audio through all of your instances that either create, affect, or output audio. So one thing that is exciting about the new API is that you can connect multiple wires to either producers or consumers. So you can have a producer of audio, like asset file playback, be sent to multiple destinations. So for instance, you can have direct sound and also send a copy of the signal through an effect bus to apply reverb or whatever other effects that you want to put. Do a wet-dry mix. Similarly, for consumers, you can receive from multiple sources, and this allows you to do things like mix buses or stems where you have a common effect applied to multiple sources. And finally, we have emitters and listeners. Emitters and listeners connect this signal processing into your 3D virtual experience. An emitter is essentially a virtual speaker in your world that receives sound and then broadcasts it into your 3D experience. A listener is the opposite. It receives sound from the 3D experience like a virtual microphone and then outputs an audio signal that you can run through effects or send to your user so they can hear it over their headphones or their speaker system. Now let's go back to our motivations for the API. So we want you to be able to build complex behavior by putting together these little building blocks and wiring them together. So to do this, we are breaking down some of our concepts that we had in the older API into smaller pieces. So if you could play the video, please. This is an example of our old API where we had a sound instance. You can see in the Explorer view that it was a child of the speaker model. And here it is, sending sound to the 3D world. That's all great. You're probably all familiar with that. Now, going on to the next video, we will show how this is with the new API. In the new API, we split this up into two components. We have an audio player that takes care of the asset file playback, and we have a separate audio emitter instance that takes care of sending this into the 3D virtual world, and then we have a wire that connects the two. So this might seem like a simple change. Together, you put this all together and you have the same behavior as before, but this simple change of splitting this apart gives you a combinatorial explosion of possibilities of how you can recombine things to have new features. So this goes on to our next motivation, unlocking new features. By splitting these apart, you can now do things that you could not do before. Here we see play the video, please. We see, again, the audio player connected to a wire, via a wire to an audio emitter. But now we have two audio emitters. We have a left speaker and a right speaker. And we also have this audio analyzer instance, which is a new thing for visualization. And this is something you couldn't do before. Before, you could not send a single sound to multiple 3D locations and have them play in sync. You can do that now. You can have a virtual PA system where you have a single audio source go to a whole ring of speakers around like an audience in a virtual nightclub. Now, I was talking about audio emitters, but this also applies to audio listeners. In the examples before, when you heard the sound, you were hearing it from kind of the default audio listener that was a child of the camera, or in some cases, the avatar head. But with a new API, you can create explicit audio listener objects, and you can place them wherever you want. You don't have to place them in the avatar's head or in the camera. You could place them in a trash can. You could attach them to a Frisbee and toss it across your virtual world. And you can create multiple listeners. So play the video, please. In this example, we have, and Dan Sturman showed this in his talk yesterday, we have an audio player, again, wired to an audio emitter. But we also have an audio listener in front of that audio emitter as an in-world virtual microphone. It's picking up the sound, and a wire connects it to another audio emitter in this other speaker object. Now, I mentioned virtual nightclub, and you can imagine you could have like an open mic night where you have a microphone on the stage and people's avatars come up to it, and the virtual microphone picks up their voices and sends it to the PA system. And that gets back to unifying voice and sounds. And all of these features I described apply to voice chat as well. By separating the producers and the consumers, we have voice chat as just another producer of sound, just like asset file playback. And it routes through all of the powerful tools that we provide you for sound design. You can apply effects to voice chat. You can route it. You can send it to multiple destinations. You can have it picked up by audio listeners. And this gives you a powerful voice chat API, which is something we know you've all been asking for, so that you can now do things like teams in your game, and control who can hear who. Thank you. So now I'd like to show this with an example video.
And each of these handheld radios has its own audio listener and audio emitter, with a couple of effects in between to make it sound like my voice is coming from a little radio. And since these radios are wired up to one another, I can get pretty reasonably far away from you, and even though my head's emitter is probably too distant to be audible, you can still hear my voice getting rebroadcast through the handheld radio that you're holding.
OK, so in this example, you saw sound effects being applied to voice chat to place that sound in world through this cheap, tinny little device. And that is awesome. We're hoping to see your giant mechs with robot voices, your little gnomes with pitched up voices. There'll be all sorts of cool stuff you can do. Anyway, this is our first release of the new audio API. We're very excited about it. We believe we've built a strong modular foundation to build new features upon. There's going to be more to come. We are very excited to see what you're going to do with this, and we want to hear your feedback. If you have more questions or want more information, please come to the Immersive Communication booth and talk to us there. And now I'll hand things over to Varun Mani, who will talk to you about aerodynamics. Thank you.
Thank you, Frederick. Hey, everyone. How's it going? This is my first RDC, so I'm super excited and a little bit nervous. So for a quick introduction, I'm the product manager for physics and geometry. We've got some of the team here, so we're very excited about this. And I'm going to be talking about aerodynamics and the Mesh and Texture API. So let's dive right into it. So as Dan mentioned in his keynote yesterday, aerodynamics is now available in beta as of last week. And this is a huge moment for us because this has been years in the making. I think you've heard of it. You've heard of aerodynamics for the last 2 RDCs, so we're happy to finally get it in your hands. And we're very excited to share this with you. So today I want to cover 3 things. First, I want to cover our long-term vision. We'll talk about where we're going. I want to talk about how you can get started with aerodynamics today. And then we'll touch on some best practices and some tips on how you can get the most out of aerodynamics. So let's dive right in. So aerodynamics is just the first step on a much, much, much longer vision we have for fluid dynamics. With fluid dynamics, we're hoping to add a whole new class of forces to the platform that's powered by fluid simulation. The goal here is to scale to every single object in your experience and to add a whole new level of immersiveness and realism to your experiences. The final goal here is we want to create more emergent behavior with aerodynamics. So aerodynamics enables a whole number of new mechanisms in your experience. To help you think about some of those, we like to think about it through the lens of 3 categories: aero first, aero enabled, and aero pervasive. So let's talk about aero first. So with aero first experiences, aerodynamics is the core game mechanic in your experience. This could be flying a realistic vehicle, or if you want to allow your users to build and test their own vehicles. The second is aero-enabled experiences. Here, you keep your existing game experience, and then you just add aerodynamics to the mix. This is really cool because you can have your avatar start to feel aerodynamic forces, or maybe it's a whole new class of obbies out there. Finally, with aero-pervasive experiences, the idea is to use aerodynamics as a way to just add a layer of realism to your environment without any scripting or animation. Sounds pretty cool, right? So let's look at how you can actually get started here. So all you have to do is, since it's a beta feature, you have to go into Studio, hit File, get into the beta features window, and then just enable aerodynamics. At this point, you'll notice in the workspace, there's a new property called the Fluid Forces property. You just click on that and then switch it to experimental, and that's it. There's no step 3. That's basically it. So at this point, what happens is that aerodynamics is just turned on for your whole experience. Every single mesh part, every single part in your experience just starts to feel these new aerodynamic lift and drag forces. So once you've enabled aerodynamics, you have 3 ways to customize it. The first is air density. So air density is a new property in Workspace. And what you can think about this is it's kind of like a strength multiplier or a force multiplier for all of the aerodynamic lift and drag forces on all your parts. Second is global wind. Global wind is just a simple vector-3 property. You can use a script to mess around with it, or you can just use the new wind direction tool with a nifty windsock. Now remember, global wind was released earlier this year, and it already affects grass, clouds, and particle effects, and those are all visual effects. But now with the aerodynamics beta, what this allows you to do is to use global wind to affect the lift and drag forces on your parts as well. So it all works together. Finally, we have a per part enable fluid forces toggle. What this allows you to do is to go into every single part and either enable or disable aerodynamic forces on that part. And this is really, really powerful, I think, because depending on your scenarios, you might want aerodynamics or not. Okay, cool. So let's take a look at a simple example here. Let's say I wanted to create an object that realistically spins in the wind as it falls. So I have this central stalk, and then I've got these two blades. So without aerodynamics, it just falls like a rock, and this is not what we want. This is what happens today. So now let's turn on aerodynamics. So now with aerodynamics, all I have to do is to go into that part and then turn on enable fluid forces. So I make it from false to true. And now when I hit run, let's see what happens. You get that. I mean, and I just want to point out here, all I did was literally I just checked a box, and then it just figured out the geometry, it figured out the air density, and then it's just adding lift and drag forces. You didn't have to do anything else. So I think that's pretty cool. So now let's add some global wind into the mix. So here I'm going to use the wind direction tool up there, and let's just add a little bit of wind in one direction here. And now when we hit play, what do you think will happen? It'll just move off a little bit to the side, right? And that's exactly what it does. You'll also notice that in the previous case, when it was just falling straight, the actual spinning motion added more stability to that object. So this is, you're thinking gravity plus aerodynamics is working together, and then we're actually doing the right thing for you. And this is all thanks to the physics engine. Once again, remember, no scripting and no animation necessary here. Okay, so let's ramp it up a notch a little bit. What about other meshes? So here I've got two example meshes. I've got a leaf that I've just dragged in from the toolbox, and then I've got a maple seed mesh that we created in Blender. So when you bring this into Studio now, we do all the calculations for you, and then over here in this experience, I'm just dropping these back and forth within those trees there. So the scripting here is just spawn and drop, spawn and drop. And you can see it all acts realistically. You'll actually notice that little maple seed over there is spinning because of the geometry, right? And again, I had to do nothing here. All I had to do is to just spawn them and drop them. So imagine what you can actually do since you can change the geometry in whichever way you like. Once again, if you noticed, if you turn on global wind, all the leaves and the seeds just move off to the side. So this, I think, is something that is brand new. It's a whole new way to add realism to your experiences, and I think it's going to be pretty exciting to see what you build. Now, what about avatars? So let's talk about avatars for a little bit. Avatars are just a bunch of parts, so avatars can also join in the fun. The only thing you need to do here is you have to enable the new character controller beta that was available late last year. You have to add the humanoid and controller manager under your starter player, and you're off to the races. So at this point, your avatar feels all the same lift and drag forces as any other part. And the really cool thing I think here is that your avatar now feels terminal velocity. So this means if you have an avatar that's falling from the sky, depending on the orientation at which it falls, depending on any accessories it has, depending on the size of the avatar, all of that is going to affect your terminal velocity, just like in real life. Okay, cool. So now a few tips to keep in mind. We talked about a lot of cool stuff. So when you're building geometry for aerodynamics, the one thing to keep in mind is always use closed meshes, because that really helps our algorithm figure out what the mesh is doing. If you're using computational solid geometry, or CSG, remember to use default, hull, or precise collision fidelity, because that will give you the best results. On the second note, on performance, so aerodynamics is meant and has been designed to work across your experience, so it only adds a tiny little bit of performance overhead to any existing mechanisms you might have. But as usual, simpler assemblies always gives you better performance. And if you want to eke out every last bit of performance from your experience, you can always use the enable fluid forces toggle I talked about before to turn off aerodynamics on any unnecessary parts. Finally, for tuning your aerodynamic forces, since it's adding a whole bunch of new forces to the system, you can always use that air density property that I talked about before to add or remove that force multiplier. And that can help you debug some things before actually jumping into the geometry. Finally, remember that enable fluid forces can also be used for different scenarios. So especially for occlusion, because we don't support that yet today, if you're walking into a building, you might want to turn off aerodynamic forces on things inside that building. We are working on proper occlusion culling down the road, but we just don't have it ready for public preview yet. Okay, so now let's talk about the roadmap. There's a lot more coming. We just talked about aerodynamics, which is the first step. And this is our entire fluid simulation roadmap. This is a multi-year roadmap, but we wanted to share it with you so you know what's coming down the line. So the first step after aerodynamics is improved hydrodynamics. The really cool thing about our aerodynamic force model is that it's been thought about as a fluid dynamic force model. So we can just take that math and apply it to water, and all the same things should just work in water, just with a different density. After that, we're hoping to get to prescribed wind. So this is where, like today, we give you global wind, which is a bulk property. But with prescribed wind, we wanted to give you localized properties to help you get more prescribed about your wind. The third thing we want to do is simulated wind phenomena. So this is for local things that we think we can do performantly, like fire or tornadoes. We can actually bring in local simulation to be part of the party here. And then after that is dynamic air and weather. And here our hope is that we can actually run dynamic weather simulations on the cloud in the server. In the cloud, that's kind of funny actually. We can actually run those on the server and then calculate it based on the terrain and other objects that you have in your experience, and then download that locally to your client, just the pieces that you need, and then run those simulations locally. So I think that would be like a massive, massive win for us if we're able to get there. And then the holy grail up here is multi-phase boundaries. So with aerodynamics or any fluid dynamics, if you've learned this in physics before, you might know that boundary conditions are really, really important and really complicated. So especially when you have things like air above water and the air actually affecting the water, that's where we get to like multi-phase boundary conditions. So with that, what I want to do is I want to showcase some of the fun creations we've created internally. You saw a quick little version of this at the keynote yesterday, that I want to show you the longer version. So are you ready for the video? Okay, cool. So let's take a watch. The part where the ornithopter like jumps up always gives me goosebumps. I really, really love that. That was made by one of our engineers, actually. Okay, so now I want to switch gears a little bit. We've talked about aerodynamics. Now I want to talk about mesh and texture API. So this is a massive, massive deal for Roblox because so far you've only been able to import meshes and import textures into Studio, but now we want to give you direct Lua access to these. So mesh and texture API, again, is just the first step. You've heard about this in the keynote, and you've heard about it with the talk just before this. But our goal is to kickstart a whole new era of creation on the platform. The goal here is to have anyone, to be not just you, but also your users, to have anyone create any kind of asset. And again, not just within Studio, but inside of your own experiences. So this is a full Lua access mesh and texture API. So it looks like some of you already figured out that we were working on this. Some of these APIs did leak, but since there was so much excitement and interest, we thought we'd actually do a quick little preview for you here today and talk about what these APIs are and how you'd use them. We'd also love to get feedback on all of this, so please come and see us at the booths afterwards if you have any other questions. Okay, so let's take a look at it. So this is a super simple demo here. Let's say I have this teapot, and let's say I wanted to create a tool that animates a shear transform on any mesh part like this teapot. So when it's finished, it should look something like this. Click on it, it does that little shear thing, and then it falls over. Right? So this is something you could never do before, but now with Lua access to that mesh API, let's see how you can actually make that work. So skipping over some of the tool boilerplate, our first step is to create a new dynamic mesh instance. And we do that through this API. Now this API can take in any asset ID for any mesh that you have on the platform. And remember, this is an async API because we might need to download that asset into your experience. And we might also need to validate if your experience has permissions to edit that mesh. Okay, so now I have that dynamic mesh set up. I can add this dynamic mesh as a child to a mesh part, and this enables real-time updates. So what this is doing behind the scenes is it's basically telling the renderer, hey, this creator wants to actually start to edit this mesh, and so please override any of the mesh part that's there now with this dynamic mesh instance instead. This step is completely optional. So if you want to do something in the background and then just show the final thing, that's totally fine as well. But in this case, since I'm trying to animate that shear, I do want to put it underneath the mesh part. Okay, so now let's get to the animation part. So because I'm going to animate it, I want to take a snapshot of the original state of the mesh. And so I can use this clone API on the dynamic mesh. And then I'm going to go through and grab the list of vertex IDs using this API called getVertices. Right? And this is what gives you actual Lua access to the vertices and the faces. So a quick note here, whenever you use getVertices or getFaces, this returns a sparse persistent ID. What this means is that if you remove any verts or faces, that doesn't reorder everything and mess up everything, and this is super important for the long term when we get to collaboration. So collaborative editing is really, really cool here. Don't worry, internally, we still use dense IDs for efficiency and for performance. Okay, now let's talk about animating that shear. So once again, I'm going to skip some of the tween boilerplate code here to update this for every frame for 1.5 seconds. And all I'm going to do here is to run through every single one of those verts, get the original position, apply the transform, and then set the position. So pretty simple stuff here. Now at this point, you'll notice that the mesh is actually partially submerged in the base plate. Right? I mean, I did this to just basically kind of show you what's going on here. So the idea here is that when you're editing dynamic meshes, the preview doesn't automatically update physics. And this is because physics is a potentially expensive operation and can take a variable amount of time to calculate the collision geometry. So this teapot, for example, takes 7 frames on my machine to calculate with default collision geometry, but it might be different for every single person. So instead, once we're done editing, we can use this create mesh part API to convert this back into a regular mesh part and also set the collision fidelity. So finally, I can use the apply mesh API to then take that create mesh part and the collision geometry and then apply that. And then the physics engine takes over and then it does its thing. So you'll see the teapot pops back out and then it falls over just as you'd expect. Okay, so now this mesh part does exist in the scene, but it's not a published asset anywhere yet. So if I close this experience, it'll be gone since the mesh part instance doesn't even have a mesh ID anymore. So this should be very familiar to you if you've used any of the in-experience CSG APIs like union async or subtract async. And this is simply the mesh part equivalent of a CSG part operation that you get out of those APIs. So it should feel very familiar if you've used any of the CSG APIs before. Now, say I do want to create a persistent asset out of this, that's totally possible as well. You can just use the new prompt create asset async, the one that was used for packages and released recently. And you can use that on a mesh part, or you can use it on straight from the dynamic mesh, and then that'll go through moderation, and then you'll get your asset at the end of that. Okay, so now I'm done editing. It's always good practice to clean up after myself, and so I'll use the destroy API to do that. I don't have to do this, but it does give the engine more flexibility to control memory usage if it knows that I'm done editing it. And it's totally fine if I want to do some more edits, I can just convert it back into a dynamic mesh and keep going from there. So there's no issues with that. Okay, so I went through a lot there. So to quickly summarize, what I did was I first created a dynamic mesh instance. I then moved that under the mesh part for preview. I cloned it and I got the vertices. And then I went into the loop where I went and got the position, animated it, and then set the position. I used create mesh part to convert it back and to set the collision fidelity. And then I used apply mesh to apply that mesh and the geometry. Finally, I cleaned up with destroy. Make sense to everyone? Okay, so now so this was a very simple a teapot example, but it does help me kind of walk through the whole thing. So now I want to show you a video. Again, it's an internal video that we created of an experience where you can actually change the hubcaps on a car. So very simple experience here, but it shows you how some of this works together. So here I've got a hubcap creation experience. You can see that the creator added some sliders here. And what this is doing is it's procedurally generating that hubcap under the hood using the mesh API. So here, as you're changing the sliders, you can see the live previews. And again, this is exactly a dynamic mesh. It's got a cool bulge function too. Now, one thing to remember here is that that is an actually physical hubcap. So it actually changes the aerodynamics of the car as well because of that aerodynamic stuff I talked about before. Again, you can always turn that off. Also, if I throw something at it, it'll actually collide because it's calculating the geometry. And you can drive off with your new hubcaps. OK, we talked about Mesh API. Now let's talk about Texture API. So Dave spoke a little bit about this with texture editing yesterday. In this demo, you can see how the Texture API is being used to paint on a body part. This is like a robot arm part. And let's take a look to see how this works under the hood. So instead of dynamic mesh, I'm going to use dynamic image here. And once again, I can add it as a child of the mesh part to see real-time updates. And again, it's exactly what you'd expect. It's just a pixel canvas. And that means you can directly modify the texture by using APIs like read pixel or write pixel. And in this case, though, I want to directly paint on that mesh. So I'm going to use something different. If you were here at the last talk, you heard about some of the AI-generated textures. This would be a great way if you wanted to do some other edits on that texture. In Experience, you could even let your users do some of that if you wanted to do it. So really, really cool stuff here. So since I want to directly paint on the mesh, I need some way to map between the 3D mesh surface and then the 2D texture space. So luckily, dynamic mesh actually gives me a function to do that as well. So what I do first is to add that dynamic mesh under the same mesh part. And then I use this new paint projection API to do exactly that. What this function does is it takes in the original dynamic mesh. You can provide it another dynamic, it takes in the original dynamic image. You can then give it another dynamic image for the brush that you want to use. Give it a projection volume, some config parameters, and then it allows your users to paint directly on the mesh. It's that easy, really. So it's easy for us, but the engineer working on this actually had a whole paper and presentation at SIGGRAPH this year on how this was implemented, but we can just use the API. So that's it. So that's how the Texture API works. We're still iterating on all of these API surfaces. We wanted to give you the preview like I just mentioned. So the exact names might change, but conceptually, this is what we're going for. OK, so let's talk a little bit about keeping things safe and accountable. So Mesh and Texture API opens up a whole Pandora's box of stuff you can do on the platform. So one thing we want to do is to make sure that safety is our top priority. Particularly when we're talking about user creation, safe real-time replication will take a bit of time for us to get right. So because of that, and this is one of our biggest challenges at the moment, and because of that, the first version that we actually ship will not support replication, but you can still publish, like I said before. So you can still take your asset or your dynamic image or dynamic mesh and then publish it out into a texture or a mesh. That'll go through moderation and will keep things safe. Our goal is to actually do this in an iterative process and take an iterative approach through this. And the idea here is that our co-creation capabilities that we offer you will simply scale up as our own moderation capacity scales up on our side. And the eventual vision is to always get to fast replication with instant moderation, but it'll just take a bit of time to get there. So with that, I just unloaded a lot of stuff on you. There's a lot more talks going on today. Remember, there's immersive communication and avatar self-expression later on today. And please, please, please come to the booths and talk to me or any one of the other engineers that are there. We'll have the Ask Me About shirt, so you can talk to us there. Thank you so much, and have a great rest of your day.